Hey everyone, and welcome. Today, we're diving into a part of SQL that honestly feels like a bit of magic. We're talking about window functions. And to really get our heads around them, we're going to use an analogy I think we can all relate to, the classic annual school photo. Oh, you remember this day, right? The one day of the year where everyone's uniform was actually clean, your hair was combed, for once. It was class photograph day. And remember how the photographer would get everyone organized? Okay, short kids in the front, tall ones in the back. And then a teacher would always jump in. Wait, let's get the houses together. Oh, the red house kids over here, blue house right in the middle. So when you look at that final photo, you can zoom in on one student. Let's call her Priya. You see her as an individual, but you also see her in context, right? You see who's standing next to her, you see she's in the second row, and you see she's part of the blue house. Her own info is still there, but she's also clearly part of a group, or what we're about to start calling a window. And this brings us to a really interesting problem. What if you wanted to see Priya's exact height, but at the same time, you wanted to see the average height of just her blue house? How could you possibly see both of those things at once? In the world of data, this kind of question comes up all the time. Now, your first instinct in SQL might be to use group by, but look what happens. Group by is like telling the photographer, just give me the average height for each house. You get your three averages, but poof, Priya's gone. All the individual students have vanished. The rows are collapsed. But a window function, that's like a magic lens. It keeps every single student in the picture and just adds that group average right next to them. And that is the magic of SQL window functions. They're that special lens for our database photographer. They let you run calculations on a set of rows, that window, without squashing all the individual rows. You get the fine detail and the big picture all at once. So to get a little more technical, what is a window function? Well, it's just a calculation that happens across a specific set of rows that are related to the current row. The key, the absolute most important part, is that it doesn't collapse your original data. And the secret sauce that makes it all happen is one little command, the over clause. So let's talk about this magic over clause. The best way to think about it is that it's the list of instructions you're giving to the photographer. It's how you tell SQL exactly how to frame the shot, how to define that window of rows that you want to do your calculation on. Okay, let's get our hands dirty with a real example. We've got this simple student marks table. We have names, subjects, and the marks they got. And our goal is to see how each student's mark compares to the average for that subject. So the very first instruction we give inside that over clause is partition by. This is, and I mean this literally, the same as telling the photographer, okay, group everyone by their house. In SQL, partition by tells the database to chop up the data into these little separate groups or windows based on whatever column you tell it to. For instance, if we say partition by subject, you can see what happens. SQL logically creates two separate worlds. You've got your maths window over here and your science window over there. Any calculation we do now will happen inside these windows, completely independent of each other. And now check this out. Here's the result. We wanted the average mark for each subject, so we wrote AVG marks over partition by subject. Look what it did. For the maths partition, it calculated the average, which is 91, and stamped that value next to every single row in the maths group. Then it did the same for science. And the best part? Priya's individual score of 95 in maths is still there. No data lost. That's the power. Okay, on to our next trick. Aggregates like average are cool, but what about ranking? This is like asking the photographer, okay, you've got them in their houses, now line them up from best to worst score. To do this, we just add another instruction inside our over clause, order by. For this, let's switch to a more, businessy example. We've got an employees table with departments and salaries. Now, I want you to pay close attention to this. In the finance department, Ramesh and Suresh have the exact same salary. That tie is going to be super important for understanding how these next few functions work. First up, the rank function. We've partitioned by department and ordered by salary, from highest to lowest. So as we'd expect, Ramesh and Suresh are tied for the highest salary in finance, so they both get rank 1. But look at Ram, the next person. His rank is 3. Rank works like a competition. If 2 people tie for first place, the next rank gets skipped. There's no rank 2. Now, contrast that with dense rank. Same setup, same tie for first place. Ramesh and Suresh are both rank 1. But look at Ram now. He's rank 2. Dense rank is dense. It doesn't leave any gaps in the numbers. This is really useful when you just want a straight sequential ranking. And finally, there's row number. This one is simple. Its only job is to give every single row a unique number, in order. It doesn't care about ties in the data. Even though Ramesh and Suresh have the same salary, row number gives them different numbers, 1 and 2. It's perfect when you just need to slap a unique ID on each row in a sorted group. All right? You ready for this? This next set of functions is where things get really cool. So we've grouped our students. We've ranked them. What if you wanted to peek at the value from the row right before you, or the row right after you? To look at your neighbors in the line, you meet lag and lead. Here's lag in action. Let's say we have monthly sales data. To see how this month did compared to last month, we can use lag monthly sales. And for each row, it literally just reaches back to the previous row and pulls that value forward. So for February, we see January sales right there next to it. Think about it. Calculating month-over-month growth just became ridiculously simple. And as you might guess, lead does the exact opposite. It looks forward. Okay, pop quiz. Let's see if this is all clicking. Imagine you're analyzing cricket data for the IPL. You've got a table with players, their teams, and their total runs. You want to find the top 3 run scores within each team. So inside that over clause, what column are you going to partition by, and what are you going to order by? Take a second. Did you get it? The answer is you'd partition by team because you want to create those separate little groups for each team, right? And you'd order by run score DESC to line up the players from highest score to lowest within each of those team windows. With that one query, you can rank everyone and then just pick off the top 3. Awesome. All right, we have all the building blocks. So let's move beyond the school photo and see how these tools solve actual business problems. We're going from photos to profits. Here is a super common business request. Find me the top 3 salaried employees in every department. Now, you can't filter on a window function directly, so we use this really clean 2-step pattern. First, we use something called a common table expression, or CTE. Just think of it as a temporary little table. In that CTE, we rank everyone in their department. Then, in the second step, we just select from that temporary table and filter where our new rank is 3 or less. It's a powerful and super readable way to solve this. Here's another business classic, calculating a running total. You have no idea how painful this used to be to write in SQL. Now, it's almost laughably easy. You just use sum sales with an over clause that orders the data by date. For every single row, SQL sums up all the sales from the very beginning up to that point. It's elegant, it's efficient, and it's incredibly useful for tracking cumulative growth. So, as we start to wrap this up, I really want you to appreciate the bigger picture here. Learning window functions isn't just about memorizing some new syntax. It's about fundamentally changing how you see and interact with your data. So let's just nail down the key takeaways one more time. First, window functions let you do calculations on groups of data without destroying the original rows, which is the big difference from group by. All the magic happens in the over clause. We use partition by to make our groups and order by to sort inside those groups. And we can use them for everything from simple sums to complex ranking to amazing period over period analysis with lag and lead. And this, really, is the most important idea of all. Window functions actually change how you think. You stop looking at your data as just a flat list of rows. You start to see every single row in its proper context, in relation to its group, its category, its previous time period. And when you can see those relationships, you can answer incredibly complex questions with surprisingly simple, clean code. So, I'll leave you with a final question to get your own brain spinning. Now that you have this new magic lens, what's the most interesting, most creative analysis you can think of?
doing with lag or lead. Think about user behavior, financial trends, inventory changes. The possibilities are pretty much endless. Thanks so much for joining this explainer, and happy querying.